Okay, so now we are going to discuss network segmentation. Network segmentation at a high level is a VRF. And the most common use case within the cloud or the multi-cloud environment is the need to segment dev and prod environments. Basically, you don't want dev to communicate with prod, and you don't want prod to communicate with dev. You want them to live as ships in the night, both operating in a completely segregated manner. Okay, so if you've done VRFs on-prem or in any service provider environment, this is a similar result. The difference here is that all what we do in Aviatrix is software defined. So we have the controller is overseeing the whole network and installing the relevant routes wherever they are needed based on the intent that the administrator configures. The gateways are not running a routing protocol between each other. So the idea is, again, we all know by now, having taken associate, that you have some spoke gateways. They are the gateways that live within your VPC next to your workloads. And there is like a hub, which is your transit, and that aggregates all of your spoke gateways. And then you can repeat the same thing in Azure. And then obviously you'll have to peer. Transit to transit connection is called a peering. A spoke to transit is called an attachment. All of these red lines are IPsec tunnels, and they're all encrypted. Similarly, you can do the same in GCP, and you can connect all of these transits. So this way, any workload within AWS can reach GCP or Azure and vice versa. Now, the idea of network domains is maybe you don't want this flat connection or flat communication where everybody is able to reach everyone. So let me just try to take you to a lucid chart where I'll explain a bit more on how it works. Just a second. So if I'm able to find it, yeah. So this is just a lucid chart where I just want to explain a bit more on how it works. So if you're not doing network segmentation, you have a prod one. Again, I've made it simple. This is a spoke gateway inside the VPC, and we have a workload inside that VPC. Similarly, dev1 is a VPC that has a gateway. It has a CIDR of 10.1, and it has an instance inside that VPC. So if you don't do any network segmentation, dev1 is going to have the route to itself, which is 10.1, obviously, and it's going to have the route to 10.2. And vice versa. If you go to prod1 gateway, it's going to have the route to itself as local, and it's going to have the route to 10.1 via the transit, and the transit is going to have both of these routes. So it's like three routers connected back to back, and they're sharing all what they know together. Now, the question becomes, what if you want to segment dev from prod? What if you don't want dev to reach prod? So this is where network segmentation comes into the picture. So after you have your spokes in the transits, you attach the spoke to the transit. But instead of allowing the spoke to see all of the routes, you basically create routing tables or VRFs on the transit. So we create a network domain or a VRF called dev and a network domain or VRF called prod. And then what we do is we associate the spokes after they attach into their relevant routing table. So prod1 is attached to the transit, but we also say, you know what, we want prod1 to be associated with the prod routing table. This way, what will happen is 10.2 will only show up in the prod routing table. So now on the transit, instead of having a single routing table, you have two routing tables. where each routing table corresponds to a network domain. And similarly, dev1, after you attach it to the transit one, you associate it with the network domain dev. So you have the routing table again on the transit, it only has 10.1. So by doing this association, prod1 here is going to be exactly the same as the prod routing table. However, so it will only see itself. And the dev1 will also be basically a copy of the dev routing table. The only difference obviously will be the next hop, which will be local. So this way, what we have done is dev1 gateway does not know about prod1, and prod1 gateway does not know about dev1. So what's going to happen in case you have, let me just annotate if I can. So in case you have a packet that goes from the instance, the first hop, if you all, I think you all know by now, is the VPC router, okay? The VPC router is the first hop. And assuming we program the VPC router with the 10/8, by default, we will do, as long as you attach the spoke to the transit, we will program the RFC 1918 routes. So the route will be 10/8, which will point, sorry, if I can just annotate again, that route will basically send the traffic towards the spoke. Now, the packet wants to go to 10.2, which is this instance, 10.2.0.10, for example. When we reach this spoke gateway, we look at the routing table. The routing table only does have 10.1, and it does not have a 10.2, so we are going to drop the packet. Okay, so this is how network segmentation can help in segregating dev from prod. They can still continue to operate, they can still function, but none of them knows about the presence of the other. It's even stronger than a firewall because there is not even routing propagation. There is no routing information propagation between the two domains. Okay, so if I were to expand the same discussion, all what I've done is instead of having it on a single transit, now I have it on two different transits. Again, I have two different network domains, which means two different routing tables per transit. So transit 1 is going to have two routing tables. Transit 2 is going to have two routing tables, one per domain. So just by the virtue of the same logic, dev1 is associated with dev, dev2 is associated with dev. This means that this gateway sees 10.1 as local, but it also sees 10.3 because it's part of dev, reachable via transit 1. Similarly, dev2 sees itself as local, 10.3, but it also sees 10.1 via transit 2. Okay, so all what we're doing is we are following the same logic, but we're just expanding it into multiple transits. What's interesting also about the feature is this is completely agnostic to what CSP you live in. This could be AWS, this could be Azure, GCP, OCI, and Alibaba. Okay, so now again, I'm still separating dev from prod, and I just expanded to have multiple spokes that live inside dev, and multiple other spokes or other connections that live within prod. The third point that I wanted to also drive home is that not only spokes can be placed inside network domains, any connection that lands on the transit, any connection that lands on the transit can be any connection that lands here can be placed in one of these network domains. So here I have an external connection from an on-prem site that is connected to the transit. Because it connects to the transit, I am able to place this connection. Reality is we are placing the connection in the prod network domain. So what's going to happen is now this on-prem site only sees 10.2 because it's part of the prod. It sees 10.2 and 10.4. It does not have the route to 10.1 or 10.3. Similarly, prod 1 sees 10.2, which is local, sees 10.4, which is again part of the prod, and it sees the 172.16 because the 172.16 is also part of the prod domain. Similarly, if you go to prod 2, you will see that it sees 10.4.local, 10.4 as local, 10.2 via the transit, and 172.16 also via the transit. So in a nutshell, anything that connects to the transit can be placed in a network domain. Sorry, let me just clear my annotations. Finally, I just want to introduce another concept, which is the concept of a connection policy. So let's now expand our use case and add, in addition to dev and prod, let's add shared services. I'm just going to focus here on dev and shared services. This is why you don't see prod in any of the routing tables. However, any network domain will have a corresponding routing table. I just removed it for brevity. So in this case, you have dev and you have shared services. But shared services is generally a place for common services. So you might put things like, I don't know, NTP, DNS, logging, other services that both dev and prod need to benefit from. So after you create the 3 domains, you realize that the dev needs to connect to these shared services. And how are you going to create a connection between these 2 domains? So there is a concept of a connection policy. What a connection policy simply is we are leaking all of the routes. We are taking all of the routes that are in the routing table of the shared services and adding it into the dev routing table, because we have configured the connection policy between dev and shared services and vice versa. What I mean by this, if you look at the dev1's routing table, you will see it has 10.1 as local. That's always going to be the case. But now it has 10.10, which is the CIDR range of the shared services. And if you look at shared services gateway, it has the route to 10.10 as itself, but it has the route to 10.1 via transit 2. Okay, so it's like you're leaking the routes between multiple VRFs. One thing to note is that you cannot choose, meaning if there were 100 prefixes inside the domain dev or 100 inside the shared services, it will be all to all. There is no way for you as of today to basically filter what gets leaked between the different domains. That is basically, I hope this is gives us a good understanding of network domains. Let me now share again my presentation now that we've explained. So again, what we're seeing here is exactly what we've discussed. So previously we had a flat architecture. Now we're adding, in this case, what is called a blue and a red domain, and you're assigning different spokes or even different external connections to these different domains. So in terms of configuration or operations, you will need to enable segmentation. So let me show you what this is all about from a configuration standpoint. So if you go to network segmentation, you will see that there is a concept of, the first step from a configuration is you need to enable it on the transit gateways. So it says here, v23 transit gateways have to be enabled to support network segmentation on them. So this is the first prerequisite. Let me just make sure. Sorry, I think you are not seeing my screen. So let me share my desktop. Just a second. Yeah, so this is what I was referring to. You need to enable it. You need to enable network segmentation. Again, you go to network domains or network segmentation. By the way, you can search segmentation. And now you're on this page. And then you go to network domains and you enable, it says v23 transit gateways have to be enabled to support network segmentation. After you do this, you create the network domains. And whenever you create a network domain, you need to decide which spokes or which connections, again, it doesn't have to be always spokes, which connections have to be part of that particular domain. And if you want to connect to another domain, this is where the connection policy that we were talking about, which we leak the routes, you can create from BU1 to BU2. Again, it's always bidirectional. So if you configure BU2 to BU1, we will automatically have it both ways. Okay, another thing you can see is if you go to overview, you're able to see the two different network domains. So BU1 is like the lighter blue and BU2 is the darker blue or purplish color. You're able to see which spokes are part of which domain. And notice because there are no arrows between the domains, it means there is no connection policy. Another way to verify is here you see BU1 and BU2, and there is no, if you have a connection policy, you'll have a line or an arc, a curved line that shows that there is a connectivity between the two network domains. Okay, the other thing, I think, again, just to try to show you the other stuff, if you go to transit gateways, I think this is a good one to note. If you go to any transit now, and you look at the gateway routes, you're able to see the full routing table, but you can also zoom in into that VRF's routing table, okay? So you can look at that in particular or look at the full routing table. Another one, if you go and look at the route DB, it shows much more information. You're able to see from each route from basically it is in which routing table in addition to other features like being able to see the AS path and the MET. Okay, so let me go back to the slides. So as I mentioned, you need to enable segmentation, you need to create the segment, you associate the spoke gateway or any external connections, and then you create the connection policy in case you want to have the domains connected. This is where it shows the segmentation is enabled. And as I mentioned, you can look at all the routes, or you can zoom in into basically into the particular routing table. This is exactly what I showed. And then in terms of connection policy, it allows inter-domain connection. Basically, it allows, like the example I gave, dev to talk to shared services or prod to talk to shared services. So basically, here what you're seeing is yellow connects to blue, and blue, obviously, whenever you do yellow to blue, it means blue to yellow. Or even if you look at the last one, blue connects to green and yellow, this will automatically see the opposite, meaning it will have yellow connect to blue because blue connects to yellow. It's always bidirectional. This is what I'm trying to convey, which is the second statement on the slide. I already showed you this, and I explained that if you want to connect network domains, you'll have to basically edit that particular domain, say, I want to connect to the other network domain. And if the domains are connected, you will see that there will be dotted lines between the two domains. Again, the two domains are denoted by the two different colors. And then if there are arrows between them, it shows that there is communication, or it doesn't mean there is communication. It means that there is connection policy being configured. Communication or data plane is a completely different thing. Okay, so next we will look at, I'll introduce the lab scenario, and we will look at the two labs, lab 1 and lab 2.